Excellent. So, unit circle. All right, here we go. The next section, we are going to use reference angles and special angles to really hammer out this unit circle. Should be pretty awesome here. Let's get rolling with it. Let's talk about what is a reference angle. Well, you can see here's the measurement angle from the x-axis. So, if I look at the 40-degree angle, so I can draw a 40-degree angle, looks like this. How does that relate to a 140-degree angle? Remember, this is 140. So what's left over here? There's 40 left over. So that's a 140-degree angle, 40 left over. What about 220? That's a 220-degree angle in standard position. It's 40 past 180. And then check out this bad boy right here. 320 is 40 short of that 360. So when we're talking about the reference angle, we're talking about this distance to the x-axis. So all of these have a reference angle of 40. And why is that important? Well, I want you to take the sine of these things. So real quick, let's just take a look at this. What is the sine of 40? Okay, great. Compare that to the sine of 140. Oh, that's pretty interesting. Compare that to the sine of 220. Any guesses here? Check it out. It just added the negative, and then we had the sine of 320. Check that out. So really, what happens here, these reference angles all have that same trig ratio. In this case, it's this crazy decimal here, but it's always the same. Yeah, the sign may change because of the negative quadrant here, but it has the same sine trig ratio. So that's what we're going to be looking at today. So most of these things are just crazy decimals. So if we're, for example, this is how we're going to see it. I may give you an angle and say, hey, what is the reference angle here? So if that's 150, we're looking for this distance. How far from the x-axis? Always from this horizontal, so it's 30. Its reference angle is 30. If I drew it in the first quadrant, it would be 30. These are the same trig ratios here. How about negative 100? So we're going to spend a lot of time drawing things, so hopefully yours looks a little bit better than that. But what is negative 100? Well, there's negative 90, so it's going to be somewhere over here. And again, if that's negative 100, I'm looking for the reference angle. So I'm saying, hey, how far is it from here? Well, how far is this? Well, negative 100 is 10 past this. So what's left over on this side? It's got to be 80. It's going to be 80 past that, past 180. So its reference angle is 80 degrees. Excellent. Very good. Some people just draw this straight across into the first quadrant. If that's 10 and 10, then maybe it's a little bit easier to see, oh yeah, these are 80 because they're vertical angles here. Awesome. Can we do it in radians? Sure, we can do this in radians. So I'm going to draw my little coordinate here, and I'm going to say 23 pi over 12. Well, I know 12 goes into that almost 2 times, right? It goes past 12 pi over 12 pi would be 1 in this case. It goes beyond this all the way over to here. Well, how close is it? Well, think about what is 2 pi in relation to 12. Well, it'd be 24 pi over 12 is 2 pi. So how close am I? Well, I was really close. How short was that? That was pi over 12 short of it. If I had pi over 12 and 23 pi over 12, it gives me, or just subtract them, and you'll get that. So its reference angle is pi over 12. So we can find reference angles for anything in the unit circle there. I'm mainly concerned, though, about these special angles. So that's great. That's dandy. Let's take a look at these special angles. I can't believe I just said dandy. That's weird. We're looking at these ones right here. 30 degrees is a special one. So this is one we have to know, and we'll talk about why this one is so special on the unit circle. So this is a unit circle. Remember, a unit circle just means it has a radius of 1. So I know that radius is 1. We actually kind of did this in application earlier. If I drop the perpendicular here, that is my reference triangle. And what do I know about this? Well, this is a 30, 60, 90 triangle. And if you remember the rule of that, if you take the long side, what do you do to find the short side? You cut it in half. So that's 1/2. And then what do you do with the 1/2? Well, you times it by radical 3. So you get radical 3 halves to get to here. So what's cool about this is I don't have, radical 3 over 2 is a crazy decimal. If you typed in cosine of 30, you get this crazy decimal. But I can write it as a nice fraction here. So this point on the unit circle is going to be radical 3, 2. I'm going over this direction and up 1/2. So this is a special point on the unit circle that we're going to know. We're going to use it so much you're going to memorize it. This is the x value and this is the y value. And so I kind of alluded to this earlier. What's nice about this? Well, if I take the sine of 30, what's the sine of 30? Well, because it's a unit circle, it's just opposite over adjacent. It's 1/2 over 1, which is just 1/2. So remember, this is the sine value and this is the cosine value. So I can find the exact value. These are the exact values, no decimal approximations, of 30. So that is a special angle. What's another special angle? Well, check out the same thing, but if I draw it way up here and I say 60 degrees, how is this the same thing? Well, drop in your little reference triangle here. I know this is still 1. What's going on here? Well, the hypotenuse is 1. I'm going to say half of that is 1/2. That's the short side. And then I'm going to do the same thing. So it's still the same coordinates. What happened though? X and Y switched. X is 1/2. Y is radical 3 over 2. So 60 degrees is another special triangle that we need to know. So we know 30 degrees. We know 60 degrees. There's only really one other one that we need, and that is going to be, boom, right here in the middle. Turns out we can do 45 degrees as well. How do I do that? Well, drop in the perpendicular. And what do I know about 45, 45, 90? So I know the hypotenuse is 1. Well, in this case, if you take it, you have to, normally I give you this, you times it by radical 2 to get to here. So here you're going to divide by radical 2. So that's 1 divided by radical 2. Since it's 45, 45, 90, these are congruent, so it's 1 divided by radical 2. Fortunately, we can't leave it like that. We don't like the radical on the bottom, so we're going to clean it up a little bit. We're going to times both by radical 2, so we end up with radical 2 over square root of 4 is 2. So these are both the same. This point right here is radical 2 over 2, comma, radical 2 over 2. So again, that is the actual sine and cosine. I know that I could come over here and type in the sine of, what, 45, let's say? So really the sine of 45 we're saying is the square root of 2 divided by 2. See how it's that same crazy decimal? The problem with this decimal is it just goes on. It's irrational. It just keeps going forever and ever and ever. So I'm going to express it exactly as this fraction. So we're all about finding exact values. These are the exact values that we can find our special angles. Awesome. So let me just label this one to make sure we have it. This is a 45-degree angle. These are our 3 special angles that we need to know in the unit circle. Fantastic. All right, so let's do it. So again, it may be weird at first, but we're going to practice these, hammer these out, and you will get good at this and faster and faster at these. It's just something we kind of have to need to know here. So let's take a look at this. So because of reference angles, I'm looking at 120. So I've got this nice unit circle. Here's 120. You know, and then what is this reference angle? Well, if that's 120, it's 60 degrees from there. So it's the same thing as this. So if I need to know the cosine value of 120, well, I got to think back to my 60, 30, 90 triangle. And in a 60, 30, 90 triangle, I know what? The short side is 1/2. The medium side is radical 3 over 2. If I plot that point, it's over 1/2 radical 3 over 2. So I really got to get good with this idea. Is what is cosine? Cosine is the x value. Remember, this goes cosine comma sine. So it's the x value. What is the x value? The exact value is 1/2. I know you could have done this super fast. You could have went over here and said, what is the cosine of 120? Got it. Oh, it's negative. What did I do wrong? Oh, good thing we checked. We got to be careful. So it is 1/2, but it's negative. Why is it negative? Well, when I'm coming over here and drawing this reference triangle, what's going on here? It's negative 1/2. So this is actually negative 1/2. So I know you can type it in, but we're going to find these exact values. This is negative 1/2 radical 3 over 2. So again, it's going to come back a little bit. We talked about this. This was the positive quadrant. This was the negative positive quadrant. Negative negative. That looks like a positive. Let me redraw that bad boy. And then the positive negative quadrant. So we're going to have to double check those as well. So we're going to probably sketch a couple of these unit circles just to get an idea and draw these bad boys in. All right. How about sine of 210? So if I think about 210, let's clear up some space here. I'll leave that, but I'll get rid of that triangle. And we'll do 210. So 210 is which one? It should be this right here. It's 30 degrees past this, so it's the same as this. So if I do my 30 degrees, remember what do I do? It's at 30, 60, 90, so I'm looking at 1/2 radical 3 over 2. So in this case, I'm going what? You can draw it straight over here. Your 1/2's over here. This is your radical 3 over 2. In this case, they're both negative. So what is the sine value? It's the opposite. We're looking at negative 1/2 over here. Excellent. How about 315? Let's draw 315 in. That should be the 45-degree one over here. And let's clean this up a little bit. Whoa, that's a big eraser. Nice. Work that right in there. Excellent. So this is 45 degrees, so it's the same as this one up here. That is not straight enough. Let's try that again. It's the same reference angle as 45 up here. But remember, when you're drawing this in, this was the nice one. This was the radical 2 over 2. Radical 2 over 2. Who's negative? In this case, it's the sine value. Or, in this case, I'm looking for the tangent. So remember, tangent in this quadrant is tangent's like saying opposite over adjacent. So you're saying radical 2 over 2 over radical 2 over 2. We're not going to say that. What is that? Anything over itself is just 1. So in this case, not only is it a 1, it is a negative 1 because the signs are different. Another way to think about opposite over adjacent for tangent is sine over cosine. And that may be a little bit easier for you. Woo! This is crazy. Kind of hurts the brain a little bit. Last one here. Let's wrap it up with, we're going to throw in a reciprocal trig function secant of 180. Well, where's 180? It's right here. Well, I didn't tell you 180, but if a unit circle is 1, this is the radius of 1. What is this point? It's over negative 1 up 0. So these are great. Anything on these quadrantals are great because it's going to be like 0, 1 up here, 0, negative 1 here, 1 comma 0 here. So what is the secant? Remember, that's 1 over cosine. So cosine is the first one, negative 1. It's going to be 1 over negative 1, which is negative 1. So you notice you're going to get a lot of the same answers here for these different things. All right, so that's good. We're going to practice a ton of these. Let's just throw it all out there. Let's go to radians, though. So can I start thinking, instead of 30, 60, 90, really what is 30? 30 is pi over 6. You can convert these, or I always just think about pi. If this is pi, I take pi and divide it into 6. That's like taking 180 divided by 6. What do you get? You get 30. 180 divided by 6 is 30. So 180 divided by 3 is what? 60 degrees. And then the middle one, 180 divided by what is 45? That's going to be 4. So again, we'll use these so much you'll get to know them, but these are quick conversions that we'll have. So if I'm doing the same reference, I'm looking at 5 pi over 4. So again, I know that's over 1 pi, and then the 4 is here in the middle. So here's 5 pi over 4. And I'm going to draw my triangle if I need it. Sometimes you won't even need it. Since it's over 4, I know both of them are this, and they're both negative. So what's the sine value? I love it when it's over 4. You can just say, oh yeah, excellent. It's got to be radical 2 over 2. So over 4 is nice. Excellent. Moving on to negative 2/3. So now I threw a negative in there. Negative and radians. Oh, love it. So I'm going to say, all right, negative 2/3. So where are my thirds? This is a third. If I'm talking negatively, that's negative 1/3, negative 2/3, because negative 3/3 would get you to pi. So I'm talking about this angle here. That is negative 2/3 pi. Drop this bad boy in. Remember, that's talking about like a 60-degree angle. So it's the special case is what? This is negative 1/2, negative radical 3 over 2. And I'm going to say, what's the cosine value? Remember, that is adjacent over hypotenuse, or it's the first one, it's negative 1/2. Wow, I feel like this is a lot. I like it though. Just keep practicing. Keep practicing. It gets easier and easier. So we're looking at cotangent of pi over 4. So I gave you one in the first quadrant. No worries, that can happen. And we're looking something like this. And that's a great one. It's radical 2 over 2 for both of my sine and cosine. I want to go tangent. So tangent is opposite over adjacent. I'm going to say that this is adjacent over opposite. It doesn't matter. It's going to be radical 2 over 2 over radical 2 over 2 either way. It's going to give you 1. But think about cotangent is upside down tangent. And then the finale, secant of 3 pi over 2. Check it out. Here's 3 pi over 2. So I'm thinking, what are the coordinates? This is 0, negative 1. And I'm going to go 1 over the cosine value, which is 0 here. Ooh, can you divide by 0? No. So we say this is undefined. There is no trig value here. And that makes sense. What would your triangle look like? Well, it's not a triangle, is it? It's just nothingness. So it's undefined. Excellent. Very, very good. So those are all exact values. Whew, can we take this and now fill out an entire table of everything? So I want to know all these different trig functions for a 30-degree angle. So again, We're only talking about 3 different angles really we got to know here. So 30-degree angle, in radians, we call that pi over 6. 180 divided by 6 is 30. What's the sine value? Maybe you have it memorized by now. If not, draw it in. And there's my angle 30. So I'm going to say 1/2 and radical 3 over 2. And if I want to look at it like this, maybe this helps out the point. So what is going on here? The opposite over hypotenuse is 1/2, the sine. The cosine is radical 3 over 2. What's the tangent here? Now we're going to have to crunch some numbers. Well, tangent is opposite over adjacent. So that's like saying 1/2 over radical 3 over 2. What can you do when the denominators are the same? A fraction over a fraction. Usually we flip them and multiply. I mean, we can do that. But what's going to happen when I flip these? Aha, these cancel. So if they have the same thing, you can cancel them there. But I'm left with 1 over radical 3, which is okay. But I need to go ahead and simplify that. So I'm going to times them both by radical 3. So on top I'll have radical 3. Radical 3 times radical 3 is 3, or square root of 9. This is my tangent value, radical 3 over 3. So fill that in the table. We got tangent. Now let's do cosecant. How do I do cosecant? Well, cosecant is 1 over sine, which is 1 over 1/2. Remember, flip that bottom fraction and multiply. So we're looking at, this is just 2. And this is a great thing. Sine and cosine are always less than 1 because that's the hypotenuse here. The trig ratio has to be smaller than 1 for sine and cosine. But when I get into these other ones, it's going to be bigger than 1 because I'm going 1 over it. So don't freak out when you get these numbers above 1. To do secant, we're going to do 1 over cosine. So it's going to be 1 over radical 3 over 2. Again, we're going to flip that second fraction and multiply. So we're looking at, what, 2 over radical 3, which is fine, but we got to get rid of that radical in the bottom. So we'll multiply by the radical. We're looking at 2 radical 3 over 3. Square root of 3 times square root of 3 is 3. So that is the simplified version of that. Crazy. And then cotangent just means what? Cotangent means 1 over tangent. So let's just flip tangent. If I flip tangent, I'm looking at 3 over radical 3. But can I do that? No, no. In fact, I got to get rid of it, so I'll do this. And this one works out nice. 3 radical 3 all over 3. A lot of 3's. Those cancel. Gets me back to radical 3. And maybe we should have done it from here. Remember that one? There it was. Before we simplify it, just flip it. We get back to radical 3. And the last thing of this little table here is, what do I call this negatively? So 30 degrees is really what? 30 degrees is really negative 330. And then in radians would be what? If we're talking pi over 6, 12 pi over 6 would be the whole thing for 2 pi. So this should be a negative 11 pi over 6, or just convert it if you need to convert it. Holy cow, that is a lot of information. I'm going to leave that up there to see if it helps. Go ahead and fill in the bottom one for this. I gave you the radians. Take a second, pause it, try it, see how you do. Okay, I'm going to start from here. So I cleared out everything out, so I had some room here. So here's the point we're talking about. Pi over 2 is 0, 1. So the cosine is 0, the sine is 1. And tangent, there's no real triangle to look at here. So yes, tangent is opposite over adjacent, but another way to think about tangent is the sine value over the cosine value. So in this case, for tangent, what is sine over cosine? Well, it's 1 over 0 in this case, which is weird. This is going to be my undefined. I'm just going to put UND there. Undefined. Excellent. So cosecant, remember, is 1 over sine. So this is going to be 1 over 1, which is nice. Cosecant is 1 over 0. Again, we can't do that. So again, it's undefined. And then cotangent is flip that. So cotangent would be what then? Cotangent would be cosine over sine. And in this case, cosine over sine is 0 over 1. This is legit. That's legal. That's going to give you 0. And then negatively, this would be negative 270 and negative 3 pi over 2. Awesome. Hopefully you got that. So just the special 30, 60, 90 and the 45, 45, 90, and then all the quadrantals, and we're good to go. Woo! Here we go. I feel like I've been talking a mile a minute. Maybe get a pause me, slow me down, and fire it up here. Love the unit circle. The finale here. So if I give you this and I say, okay, theta is some angle between 0 and 360, somewhere on the unit circle here, find theta. So where is sine 1/2? So now I'm kind of doing it backwards. I'm saying, okay, I'm looking for sine to be 1/2, like this. This is the 1/2. So in this case, this point is radical 3 over 2, 1/2. Haha, the sine value is 1/2. So I know that's what. Remember, this angle is the 30-degree angle. But is that the only place it's 1/2? No, it happens again. Remember, over here it's negative 1/2. It's also negative 1/2 over here, positive 1/2 here. So I got to think about, okay, what is this angle? Well, it's 30 above 180, so it's happening at the 150. So again, draw some pictures. I would have these signs in this quadrant. This helps me out with my cosine and sine. My sine signs. My signs got signs. All right, so there are the things right here. And let's keep going. Where is cosine 1/2? So it gets to the point we do these so much that you're going to kind of just know where these things are. But cosine's 1/2 is when you want the first one to be the short one. So we're looking here at this one. You want this to be 1/2. So that's my 60. So I know in 60 is positive. Where else is cosine positive now? Cosine's positive here and here. So what is 60 degrees in this quadrant? Well, it's 60 less than the 360, so it's going to be 300. So we're kind of bouncing around the unit circle here. All right. How about the next one? When is tangent -1? So tangent is 1 at these special cases when that's sine over cosine. So that's when we're looking at these radical 2. It's the same thing, radical 2 over 2 or radical 2 over 2. So where's tangent negative? It's going to be at one of these 45s. Which 45 has a negative tangent? Well, it's when the signs are opposite. So it's going to be in quadrant 2 and 3. So that's 45 short of 1. Remember, this is 180. 45 degrees short of that is 135. And then it's also going to happen down here. 45 short of 316. 360 is 315. Whew. All right. 3 more. Holy cow. This hurt my brain a little bit. The sine equals radical 3 over 2. So if I flip this point around, we're looking at this. And when does this happen? When is the sine value radical 3 over 2? It's going to be 60 degrees. Where else is sine positive? It happens over in this quadrant. So if that's 60 above. We're looking at 120. Excellent. And where's the cosine 0? I don't know. This is going to be one of those quadrantals. So this is going to be 1, 0. 0, 1, negative 1, 0, and 0, negative 1. Cosine's the x term, so it's going to happen on the y-axis, which is 90 degrees and 270. And then where's cotangent undefined? This is when I start thinking about cotangent is really equal to what? Tangent sine over cosine, so this is cosine over sine. So you can't divide by 0, so I'm looking for a sine. This is like saying when is sine 0? Sine is 0, it looks like right here, at 0 degrees, or 360 if you want to call it, and 180. So it's 0 degrees and 180. Awesome. I think in the practice, I'm going to ask you to do this in radians as well, but it's just the same idea, just kind of calling them in radians. And I'm giving you a ton of practice. You're welcome. You're welcome for that. Don't freak out when you see like 59 problems. They go fast. We got to just kind of practice these. And on the match check, I'm not going to give you any pictures or unit circles. You're going to have to draw it all yourself from scratch to answer these bad boys. But I cut the application really short, so don't freak out there. We're going to wrap this up with a feral happy parody here that's pretty funny if you like funny videos. All right, good luck on the match check. Peace out.
It might seem crazy what I'm about to play. The off is on, I'll never get away. I'm a small pixelated bird with a heavy face. In the air, like I don't care, there's a pipe in the way. The bird is floppy, tap the screen if you feel that fluffy bird. took it down. Would you please specify why you took it down? Oh, well, I'm topping now. Can bring me down.